Hello everyone, my name is Vanashri and I am here to discuss on the topic challenges in implementing color image processing. Color image processing is an integral to the modern technology. It powers applications like digital photography, medical imaging, video streaming and autonomous systems. However, as with any complex domain, it comes with challenges. In this session, we will explore fundamental and foundational concept, dive into the challenges of processing color images and discuss the potential for the innovation in this field. So, let's begin. Firstly, we are going to see the foundational concepts in color image processing. To build a solid foundation, let's first understand the key concept that underpin the color image processing. The first one is color space. RGB, red, green, blue. It is an adaptive model combines red, green and blue light to produce all visible colors. It's ideal for the display but not suitable for printing. The next is CMYK, cyan, magenta, yellow, black, a subtractive model used in printing. It represents the color as the absence of the light, which makes the color a challenge during RGB to CMYK conversations. The next is HSV, hue, saturation and value. This is more model for the human perceptions. Like the hue represent the color type, saturation its intensity and the value is its brightness. Each color space serves as a purpose, but choosing the right one depends upon the applications. The next is color quantumization. This process reduces the number of a color in an image to improve the efficiency and save storage. For example, the GIF image often use an 8-bit palette with only 256 colors at maintain visually appealing. The next is color histogram. A color histogram are tools that display the distribution of the color within an image. These are useful for comparing the image, analyzing the color composition for the task like object recognition. Let's think about an example. When we enhance photos on our phones, tools like saturation and brightness slider work based on this principle. The next is challenges with color space conversations. First one is accuracy. During conversions, there often a loss of information. For an instance, converting an RGB image to CMYK for printing can result in muted colors. Maintaining a color requ- requires some precise algorithms. The next is computational cost. Real-time applications like video editing need to convert color spaces on the fly. This can be computationally expensive, especially for high-resolution image or a videos. The next is subjective. Color precision varies between individual and application. A bright red in an advertisement might need more muted tones in a medical image. Tailoring algorithms to this subjective requirement adds the complexity. Let's think of how colors appear different on your phone screen versus the printed material. This happens because the different color spaces use the limitation in the conversation. Now let's see what are the limitation of color segmentation algorithm, the noise and artifacts. Digital image processing often contain noise, random variation in pixel intensity. Noise can create a false region during the segmentation, affecting accuracy. Next, the color variability. Colors look different depending upon the lighting and surface property. For an instance, a yellow object under a blue light appears greenish. Algorithm must account for this variation. Next is the computational complexity. Advanced segmentation method like deep learning need a powerful professionals and effective memory. This can be a limitation for low power devices. For an example, in a traffic signal, color segmentation is used to detect vehicles based on the color. However, changing light condition, shadows, or weather can interfere with this effectiveness. Have you ever used a photo editing app that struggle to detect the edges of an image? This is a practical example of segmentation challenges. Object detection is a fundamental application of color image processing. However, when it based on the color, several challenges arises. The first one is camera calibration. Different camera captures different colors differently due to the variation in sensors and setting. Ensuring consistent color representation across the devices required rigorous collaboration and calibration. Lighting variability. Object appears differently under diverse lighting condition. Consider how a red car looks under daylight versus street light. Algorithm must adapt to the changes. The next is shadow and occultations. Object may be partially hidden or cast shadows, making it difficult to detect them accurately. For example, a pedestrian leg hidden by a vehicle might confuse the system. In the real world, like think about an autonomous vehicle, their object detection system must function already certain challenges like low light or complex urban environment. Next, let's move on to the difficulties in color guided image enhancement. Enhancing an image visual appeal or detail is common application, but it comes with certain challenges. The first one is the preserving details. Improving contrast often lead to the loss of finer details. For example, in medical imaging, losing certain details can be critical consequences. Next, the color balance. Achieving natural looking results while enhancing the color can be tricky. Like oversaturated images might look unnatural while under saturation can dull their appearance. The third one is the noise reduction. Reducing the noise while avoiding the artifacts is another challenge. Noise reduction algorithm must strike a balance between clarity and realism. So, have you ever used an image filter that made a photo look fake? This is an example of poor color enhancement. Now, let's move on to the color consistency and white balance. Color consistency ensures that the color appear same under varying lighting condition. Let's explore the components. Illuminate identification. Identifying the light source is the first step and is its natural sunlight or a LED bulb. Each affects colors differently. The next is color adaptation. Once the light source is identified, the system adjusts the color to suit the images. The next is white point adjustment. Setting a reference white point ensures that whites appear whites, which is essential for accurate color representation. This is especially important in the photography where improper white balance can make a photo look warm or cold. Think of how photos taken under artificial light often have a yellowish tint. Adjusting the white balance fixes this. In conclusion, Color image processing is a fascinating field with both challenges and opportunity. Key challenges like computational efficiency, adaptability to diverse conditions remain area of active research. The future directions are deep learning. Advanced neural network promise better segmentation, detection, and enhancement capabilities. Hardware optimization. Specialized processors can make computational intensive tasks more effective. The next is color prediction modeling. Understanding how human perceive color can help design better algorithm. I hope this session has provided a valuable insights into the complexity of color image processing. So now let's discuss what are the expected questions in this field. So the first question is define and explain the concept of color space in image processing. For this, the expected answers are you have to describe the RGB, CMYK, HSB and their application in detail. The next question is what is color quantization? Explain its importance and provide an application of this applications. The expected answer is you have to provide a reduction of the color in an image to optimize the storage and processing. The next is what is the role of color histogram in image processing? How are they used for image comparison? For this, you can explain the histograms as the tools to visualize and analyze the color distribution. The next is discuss the challenges faced during color space conversion. Provide example of these challenges affect applications. For this, the expected answer is you have to explain the accuracy, computational cost, and subjective issues. The next question is what are the limitation of color segmentation algorithm? How can a noise and color variability implement the segmentational process? For this, you can answer like discussion on the noise interference, lighting variation, and computational concept complexity concepts. The next is describe the challenges in implementing color based object detection. Discuss the role of a camera calibration in addressing these challenges. In this, you can explain the light variability, shadows, and calibration method. The next is what are the difficulties faced in color guided image enhancement? How can we preserve details while reducing the noise? For this, the expected uh, answer is like you have to explain about the detail preservation, balance contrast, and using filters for the noise reduction. The next one is what are the future research direction in color image processing? Discuss the role in deep learning in this field. So for this, you can mention the advancement in computational efficiency, color perception modeling, and AI integration. Thank you.